This is how the light travels inside a glass slab. Let's say this is the incident ray. It gets refracted and travels inside the glass slab, and then again it comes out. Here, refraction is happening twice. First, when the light is entering the glass slab, it gets refracted, and the second time, when the light ray leaves the glass slab into the air medium. The incident ray and the emergent ray are parallel to each other. Let's understand how this works. We have seen when the light ray enters a glass slab, it bends. But what is the reason for it to bend towards this normal inside a glass slab and away from this normal when it comes out of the glass slab? The reason to bend towards the normal when it comes from air medium to glass medium is in the change of speed of light. Light ray travels quickly in air medium, which is a rarer medium, and it slows down inside a glass slab, which is a denser medium. Let's look at this in detail. This is our incident ray, and for simplicity, let us consider this as a light particle. Now, when it reaches the glass slab medium, this part of the light ray enters the glass slab, whereas the other part of the light ray is still outside. Once it enters the glass slab, the speed of this drops down and travels only a very small distance, whereas at the same time, the speed outside the air medium is very high and travels more distance, which will cause the light ray to bend. Once it enters the glass slab, it goes on with the same speed, and then again when it is leaving, it bends away from the normal. Now let's look at laws of refraction of light. The first law says the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. The second law of refraction says the sine of incidence angle to the sine of refracted angle is a constant for a given color and for a given pair of medium. This is known as Snell's law. And this constant is the refractive index of the second medium with respect to the first medium. Let's look at the speed of light in different mediums, which is the cause for the refraction of light. In vacuum, it is 3 lakhs km per second. In air, it is 2,99,910 km per second, which is slightly lower than the speed in vacuum. In water, it is relatively less, 2,25,563 km per second, and the least is in the solids. For example, in glass, it is 1,97,360 km per second. Why does the speed of light drops from vacuum to air to water to glass? In vacuum, as there are no particles, light can freely move in. Since there are fewer particles in air, speed of light is almost equivalent to vacuum. In water, as the particles increases, the collision of the light particles with the molecules also increases and hence the speed comes down. Solids have the most number of particles in them and more number of interactions and collisions, and hence the speed of light is the minimum. Refractive index of medium 2 with respect to 1 is equal to the ratio of speed of light in medium 1 to the speed of light in medium 2. Refractive index of a medium is defined as speed of vacuum to the speed of light in that medium. Refractive index of medium in air is 1.0003, in water it is 1.33, in glass it is 1.52. This you get when you divide the speed of light in vacuum by speed of light in glass. Optical density is a term used to denote the refractive index of a medium. Higher the optical density, higher is the refraction, and lower is the speed of light in that. Here in this case, when light enters a glass slab, it enters from a rarer medium to a denser medium. Here, glass slab is optically denser than air. One point to note here is, optical density is not related to mass density. Optical density is just about the relative speed of light in that medium compared to the other medium.